welcome back to the channel. So as you can see here, we have three logical operators. The first is AND, then we have OR, and lastly NOT. Now, each of the logical operators produces a Boolean value of true or false based on the logical relationship of its arguments. Now, this example here uses the relational and logical operators. If you haven't seen my video on relational operators, I'll link it in the video and in the description below so you can go check it out. Now, in this program, we create a random object to generate numbers, and for that we use the Java util library. Now, if you create a random object with no arguments as we did here, Java uses the current time as a seed for the random number generator, and because of that, it produces different numbers for each execution of the program. Now, here we have two integers, I and j. And to get the number, we have to use nextInt, the nextInt method of the random object, and we pass it a value of 100 so we can get numbers between 0 and 100. Now here I just printed out I and j, the values of I and j, so we can know what numbers we're working with. Now finally, here are the logical expressions. This is the first logical expression using the AND logical operator, and as you can see on the left and right side we have relational comparisons. First we check whether I is less than 10, that's the first relational comparison, and then we check whether j is less than 10. Now how this works: for this whole expression to be true, the left side has to be true and the right side has to be true. In any other case, the whole expression is false. So this is how the program works. First, it checks whether I is less than 10. If it's true, it'll check the second comparison and give us an answer of true or false. Now, if this first comparison is false, now something that happens here is called short-circuiting. It won't even check this comparison because it will know right away that the whole expression is false. And in the next video, I'll talk more in details about short-circuiting and why it's good, and I'll show you an example of how it really works. And same thing with this OR operator. First, it will check whether I is less than 10. Now, if it's true, it won't even check the second comparison because it will know that the whole expression is true. However, if this is false, the left side, then it has to check the right side, because if the right side is also false, this whole expression will be false. So OR is true in all cases except for when the left and right side are both false. Now here I showed you an example of the NOT operator. If we do not true, we will get false. Also, if we do not false, we'll get true. Here I'll just run the program so we can see the result. As you can see here, we have 90 as I and 56 as j. So is I less than 10? Is 90 less than 10? False. So the whole expression will be false. This won't even be checked. Now let's see this. Is 56 less than 10? It's false, but it has to check the right comparison as well, because if this is false, which it is, then the whole expression is false. That is, it doesn't know the answer until the second part is evaluated as well. And also here we have false because not true is false. So as you can see, you can apply the logical operators to Boolean values only. You can't use the non-Boolean as if it were a Boolean in a logical expression as you can in C and C++. So you can see the failed attempts to do that in the comments here. For example, doing I and j simply won't work in Java because you can't treat an integer as a Boolean value. However, the expressions that did work right here, they worked because they produced Boolean values using relational comparisons. That is, this is the first relational comparison, then this is the second. They both produce Boolean values, and then we use the logical operations on the results. That is, we use the AND operator on the results that we got from the comparisons. So I hope you understood everything, and I'll see you in the next video. Bye guys!